Now let's take a look at an example of a hyperbola. So this equation is a general form of the equation of a hyperbola, and we will want to change it to the standard form in order to find the attributes of this hyperbola. Now this will be a horizontal hyperbola. A vertical hyperbola works very similarly. And we will have x minus h squared over a squared minus y minus k squared over b squared equals 1. So it looks very similar to that of the standard form of the equation for an ellipse, except for this sign right here is changed from an addition symbol to a subtraction symbol. And that's how you can tell that it's a hyperbola. And h and k will be the center. 2 times a will be the distance between the vertices. C squared equals a squared minus, or a squared plus b squared, where c will be the distance from the center to the focus, and c over a will be the eccentricity. And for a hyperbola, you should always have an eccentricity that's greater than 1. So to begin, let's go ahead and make sure all of the variables, everything with an x or y term is on the left side, and everything else will be on the right. So we'll just add 79 to both sides. Then let's go ahead and group all the x terms together and all the y terms together. Then we'll factor out the coefficient in the x squared term and the y squared term. So for the x squared term, we'll factor out a 9, so that we have 9 times x squared minus 6x. And for the y squared term, we'll factor out a negative 16, so that it's a minus 16. And then we're left with y squared minus 2y. So make sure that you can see that we're factoring out a negative 16 here. And so that's why the sign will change. Then we will be completing the square. So we'll complete the square for the x term and the y term. And we'll do that by adding that middle term, divide by 2 squared, to each piece. So for the x squared minus 6x, we will have negative 6 divided by 2 squared, so we'll add 9. We'll have negative 2 divided by 2 squared, so we'll add 1. And then we have to make sure that we account for it on the other side of the equal sign. So in order to do that, we'll do plus 9 times 9, because it'll be 9 times 9, minus 16 times 1, and the 1 comes from right there, so minus 16 times 1. Then let's factor out what it is, or factor what's inside of each of these parentheses, so that we'll have x minus 3 squared and y minus 1 squared. And then we simplify the right to get 96. And then just like the ellipse, we want to divide everything by this term. So we'll divide everything by 96. So divide by 96 because we want that 96 to become 1. So everything must be divided by 96. And when we do that, this will become a 16 and this will become a 9. 16 over 96 will reduce to be 1 over 9. So that's how we get these bottom terms. Now we have this as the standard form of the horizontal hyperbola. So let's pick out the attributes about it. So we'll have the distance as 3, 1, or sorry, the center as 3, 1, the distance between the vertices as 8, the C will equal 5. So remember that's the distance from the center to the focus. And the eccentricity will be 5 over 4, which is 1.25. So it's greater than 1, which is what we wanted. And start kind of plotting these points. So this is the center at 3, 1. Then we have our 2 vertices. So the 2 vertices will show us where our hyperbola will go through. And those 2 vertices will be negative 1, 1, and 7, 1, because the distance between them is 8. So that means it's 4 away. So 3 minus 4 is negative 1. So that'll be there. 3 plus 4 is 7. So that'll be there. And then we can just put our hyperbola through them. There's also a way to find out these asymptotes. They're the vertical asymptotes. But I'm not going to go through that in this video, but feel free to check that out. And that way you can make your hyperbola a little bit more into its shape. But for our purposes right now, this is a pretty good sketch of the hyperbola that we want.